Algebra 2, Concept 25, Teacher Talk, logarithmic functions and inverses. So first we're going to rewrite each log function in exponential form and each exponential function in log form. So if you look at A, this is a logarithm, and you can tell because you see log in the equation. So you can use that motion that we talked about in the notes, where you start up top and swing around, to help you know what order you would read this in. So it is base 7 raised to the third power equals 343. So your eyes start up top of the log and they swing down, and the first number that they see is the base, and then they swing around the equal sign, that's the power, and come back to the left side of the equal sign, and that equals the value. So 3 to the negative 1 power does equal 1/3. Now C and D are exponential equations, and we need to rewrite them as logarithms. So I think I just build my logarithm one piece at a time. So I start by just writing log, and then I locate the base, which is 125. Then I locate the value, which is 25, and that goes next. And then finally the exponent, and that's what the logarithm will equal. Do a final visual check just by swinging around and making sure that all those numbers are in the correct place. Now look at D. 3 squared equals 9. So let's build the logarithm. So write log, locate the base, that's 3, then the value, which is 9, and then finally come back to the exponent, and that's what a logarithm equals. So it's good to be able to rewrite log functions into exponentials and exponentials into log functions. Now we're going to find the inverse of a log function. So the first thing that we do is we just interchange our x's and our y's. Our inputs and our outputs literally switch in this case. Then we're going to solve for our new y. So we're going to start by subtracting 13 from both sides. Then I'm going to just switch sides, so I have my logarithm expression on the left of the equation. It's easier to work with. I'm going to rewrite my logarithm as an exponential. It's understood base 10, so 10 to the x minus 13 power equals y. And then I'll just rewrite that in y equals form. So the equation that is the inverse of our original log function is y equals 10 to the x minus 13 power. Now let's graph this function. So it's y equals log base 3 of x plus 2. So we have an h value of negative 2. That means that our graph is shifted 2 to the left. So we're going to take care of that in our table, subtract 2. So now we're just going to ignore the h value when we find values in our table. And we're going to think of our logarithm in exponential form. So that would be 3 to the y equals x. It's easiest to put in values for our exponent, so for our y in this example. And then from our x values, we will subtract 2, and that does our shift algebraically. So draw your xy axis, label a scale, and then plot those points. And my graph is going to be in orange. So I'm using my orange values for x and the blue ones for y. Notice the shape of the logarithm, and that it does not go up against the y-axis. It is going up against the line where x equals negative 2 because of that shift. That's called the asymptote. All right, and this concludes our teacher talk for concept. I believe we're on 25.